So you can see that the line goes towards the Z axis and the value of the point was 0, 0, 3. So if 0, 0, 3 has been written, that means the line will go in X, that is 0, Y 0, and it will go at the top at 3. Now if you just move the view cube, now how to move that view cube? So you can click on the points over here in the Z axis, in the view cube. Now you can see the various directions in which the line can be seen. Now this is the right direction that you can see that how the line has moved from 0, 0. Then we had in X 3, 0, 0. That means 3 units from in X from the origin, 0 from the origin, 0 in Y in the origin, and 0 in Z in the origin. But now when we are going from this point and we are saying that the line would, the end point is in X it is 0, Y it is 0, and Z is 0, Z it is 3. So AutoCAD basically finds a point at X0, Y0, and Z3 and gets it over here. Now let's say again, let's start the point from 0 in X, 0 in Y, and 3 in Z. So it starts from here, and if I say the next point is 0, 0, 0, that is 0 in X, 0 in Y, and 0 in Z, the line basically goes to the origin and press enter. Now you can see that a triangle is created at the XZ plane. When two axes meets, it becomes a plane. Similarly, just I am moving the view cube. You can also try. So if I want to draw a line again, and I started from 0, 0, 0. Now I am using the absolute coordinate system. So in the absolute coordinate system, all the points are basically referred from the origin, as you have learned. So now I started from here, and I want a line 3 units in Y axis, but 0 in X and 0 in Z. So I will put 0 in X, 3 units in Y, and 0 units in Z. So the line is created here. Now let's say if I want to go up in the Z axis. Now here the value of Y is 3 and value of X is 0. But if I want to go up, it means that I have to retain the value of X as 0, Y as 3, but now the Z would be 3 units, no? So it moves up. Now if I want to close this particular, I want to face and I want to come here. So this point is 0 in X, 0 in Y, and 3 units in Z. So I would say it is 0 in X, 0 in Y, and 3 units in Z. So, and press enter. So now what I am doing is I am creating some 3D wireframe. So this is the wireframe because I am creating a 3D model with the help of lines, which we call it as wireframe modeling. Now it is not a solid, neither it is a surface. It is completely wireframe modeling. Now if I want to draw a line, now just I'm switching off the view cube to get an appropriate view. So I want to start from this point. So this point is 3 in 0 in X, 3 in Y, and 0 in Z. So let's start 0 in X, 3 in Y, and 0 in Z. So I start from here, and I want to create a line in the X axis. Let's see what is the distance that with the distance tool we can check what is the length. Length is 3 units. Okay. So I started from 0 in X, 3 in Y, and 0 in Z, and I would go 3 in X, 0 in Y, 3 in Y, and 0 in Z. Why 3? Because we already have a value of 3 over here. So press enter. So it will be, and then I want to join this face. So this face is basically, if I want to have this XY face over here, this point would be 3 in X, 0 in Y, and 0 in Z. Now you can see that we are about to create a wedge, Only thing is that I have to join these 2 points. Now what would be this point? You can think of it, but if you want, you can do it of yourself or you can follow my instruction. Now if I want to start the line from this point, so what would be the coordinate? The coordinate would be 0 in x, so there is no value in x, 3 in y and 3 in z. So I would say 0 in x, 3 in y and 3 in z, and then I want to have this point. So this point is 3 in x, 3 in y and 0 in z. So with this now we created a wireframe wedge. So we'll be doing more exercises of wireframe, but the coordinate system that I have used right now, friends, this is coordinate system is the absolute coordinate system. So now coming back to the coordinate system. So the absolute coordinate system, as you are seeing that here, this point is 10, 6, 6. That means from the origin, this is 10 units in x, 6 units in y, and further it goes 6 units in z. So this is the absolute coordinate system. Next is the relative coordinate system. So in the relative coordinate system, you know that in the 2D system, it was a polar coordinate system and a relative rectangular coordinate system. Here we are having 3 coordinate systems. One, the relative rectangular coordinate system, the relative cylindrical coordinate system, and spherical coordinate system. So the polar coordinate system is now subdivided into cylindrical coordinate system and spherical coordinate system. So we would be seeing various examples of how we are utilizing all the 3 coordinate system for the relative coordinate system. We'll create the same figure that we have created in the absolute coordinate system. So let's start. We'll start with the rectangular coordinate system. So we go with again, we'll create a wireframe. We have a line. So the first point is 0, 0, obviously. And the next point, I want to create a 3-unit line in the y-axis. And and nothing in x and z. So I would say at the rate 0 in x, 3 in y, and 0 in z. So here I have this particular line of 3 units. Now if I want to go in the z direction, positive z direction, so I would say at the rate 0 in x, 0 in y, and 3 in z. So I'm here. Now if I want to create a line in the negative y direction, I would say at the rate 0 in x, minus 3 in y, and 0 in z. And then I can close it. So I have a face that is created in the YZ plane. So I'll be creating the wedge from here. So I'll be creating an inclined line over here, not similar to the figure that we have created, just changing the face at this particular example. Now if I want to create a line from this point, so I click over here, so or I go with 0, 0, and I want to create a line in the x-axis. So I would say it's very simple, at the rate 3, 0, 0. So I create a line, and then I want to create a line in the y-axis. I'd say at the rate 0, 3, 0, and C4, and then I can say at the rate minus 3, 0, 0. So here I have these two faces, one in the YZ plane and the other in the XY plane. Now let's say if I want to create a line from this point to this point, I can pick from the absolute coordinate system or just click into it. And then if I want to create a point over here, so what I'm doing is I'm going down -3 in Z axis and +3 in positive in X axis. There is no movement in the Y axis. So I would say that at the rate I want to move 3 in X, 0 in Y, and -3 in Z. Similarly, if I want to move from this point, the same thing will happen. So I say at the rate -3 in X, 0 in Y, and -3 in Z. So this is what I have created, something that is in the that is basically created with the help of the relative rectangular coordinate system. Now, the other coordinate systems that we can use is the polar coordinate system. So, the polar coordinate system has two coordinate systems. One is the spherical coordinate system and the other is the cylindrical coordinate system. Let's see what are these. So, if I'll start with the spherical coordinate system. Over here, I define a point with respect to the previous point, and I have two things. One is the length, other is the angle that I have to define. Now, in angle, I have to define two angles. One, the angle from in the xy plane, and the other angle is from the xy plane. Now, to explain this better, I would take some examples. Now, let's say if I have a line, I'm drawing from the origin, and this line is 3 units, angle is 0. So, I'm using polar coordinate system 2D. Now, if I want to incline this line from the xy plane at 45-degree angle, that means the line will go in the z axis. So how do I do? I can incline the line in the xy plane by rotating it, or let's say 0, 0, 0, and then from here I can say that press enter. The first point is 0, 0. So first point is 0, 0, 0, or you can say 0, 0, and then we can say at the rate 3 angle 45. That means this particular angle is in the xy plane. But my case is something different. I want to incline this line not from the x-axis but from the plane so that it goes straight here. So here what I need to do, I need to use the polar coordinate system, and that is also spherical polar coordinate system in the 3D environment. So here when I define a line, the first point is 0, 0. So as polar coordinate system, this line is at an angle of 0 degree. So I say at the rate, the line length is 3 units, angle with the x-axis is 0, but the angle with the xy plane is 45 degree. Now here you can see that, just showing you for reference, rotating it, this line was basically at 0 degree with the x-axis, but now this line had inclination with the xy plane. So if you see the front view or the you can see in the view cube, there are, if you look with the front view, you can see how the orientation is done. So this is the line which was created at 0 axis with the 0 with the x-axis, 0 degree with the x-axis, and 0 degree with the xy plane. But this line is at the z-axis, which is having an angle of 0 degree with the x-axis, but an angle of 45 degree with the xy plane. So this line is having an angle of 0 degree with the x-axis, but it is inclined at an angle of 45 degree with the xy plane. So let us do another example. Let us create another line at 2D plane, that is xy, and then we will rotate it at 45 degree with the xy plane with the help of spherical coordinate system. So in the spherical coordinate system, as you see that, you define a line by the length, the angle with the angle it makes with the xy in the xy plane, and the angle it makes with the xy plane, in the xy plane and with the xy plane. So two angle components are there. So let's take another example. Now here I'm just erasing this. I have this line which is, let's say, 3 units, and its angle with the x-axis is 0 degree. Now I have another line which I start from 0, 0, 0, and the length is 3 degree, and this line is at an angle of 45 degree with the x-axis. So the line looks like this. So if you look into the top view, the line will look like this. So now I want to have similar line of length 3 units with an angle of 45 degree with the x-axis. So let me do a dim angle here. So Dimang. So this is the angle that the line is making with the x-axis. Now I will draw a similar line which is at an angle of x-axis, say 45 degree with the x-axis, but also having a 45 degree angle with the xy plane. So let's draw a line 0, 0, 0, and at the rate 3 is the length, angle with the x-axis is 45, but the angle with the xy plane is also 45 degree. So just rotate the view cube to see what happens. Now this is the line which is in parallel, which is in the plane, this particular line in the plane, same plane, but it is having angle of inclination of 45 degree with the x-axis, but also 45 degree with the xy plane. So the line becomes like this. So this is spherical coordinate system. We will do one application based on this. And then we have the cylindrical coordinate system, which says that here, if you are using the coordinate system, you give two things. Number one, in fact, three things. Number one, what is the length of the line? Okay, what is the length of the line? What is the angle it makes with the x-axis? And what is the distance that the endpoint makes with the xy plane? Here we have the perpendicular direction of this point from the xy plane. Now let's do like this. So if I have a line, let's say I'm creating again 0, 0, 0. I say at the rate 3, 0, 0. So I have this line in the x-axis. So I can create this line by again 0, 0, 0, and I say at the rate 3 angle with x-axis 0 and angle with xy plane 0. Now I am using the spherical coordinate system here. But now if I am planning to use cylindrical coordinate system, I have to give one illustration. Let's say if I have a line here which is at a height of 3 units from this point in z axis. So I will say at the rate 0, 0, 3. Now suppose here this is the depth of the point. The point moves from this point to this point. So if I want to create a line of this length, and angle with the x-axis is 0, but the depth of this line is 3 units, so it will be created like this. So let's take an example. So with the cylindrical coordinate system, so the first point is 0, 0, 0, and the next with the cylindrical coordinate system at the rate length of the line, angle with the x-axis, then put a comma, and the distance that it makes with the xy plane is 3 units. So you can see that it just basically creates a line of length 3 units, angle with the x-axis is 0, and the z depth is 3 units. Now let's take another line. So line, first point is 0, 0, 0. Next point is same at the rate 3 angle 0. But here I take the depth as 5 units. Now what will happen? This depth now will become 5 units. So if you basically rotate the view cube, you find that this line is linear with this line, but the depth of the line is 5 units. So there are different coordinate systems that we can use. In relative, we have a rectangular coordinate system, we have a cylindrical coordinate system, and we have a polar coordinate system. So we'll do some application based on this. Now let's create a cube of 3 units side. That means a cube will be having length, width, and height as 3 units, and we'll be using all the 3 relative coordinate systems. That is the rectangular coordinate system, spherical coordinate system, and we will be using the cylindrical coordinate system to create the cube. So again, remember that we are creating a wireframe model. So in 3D modeling, we have got 3 concepts. One is the wireframe modeling, other is the surface modeling, and then is the solid modeling. So wireframe modeling is the basic modeling technique where we show different kinds of line works in different axes. A 3D line work can be shown with the 3D model of wireframe model can be shown with the line works. So let's create the default view over here. So we can also change it towards ourselves if we want to see the XY viewing our eye. So let's start. So now we'll be creating a cube of 3 units. So line will start with 0, 0, 0. Now, first of all, I want to create the face in the XZ plane. So I have to go in the Y axis. In the YZ plane, I have to go in the Y axis first. So I'll say at the rate 0 in X, 3 in Y, 0 in Z. So which coordinate system I have used? I have used the relative rectangular coordinate system. Again, I will use the relative rectangular coordinate system to go in the Z direction. So I'll say at the rate 0 in X, 0 in Y, and 3 in Z. So I am using the rectangular coordinate system. For this face, I'll be using the rectangular coordinate system. Now, again, if I want to go in the negative Y direction, so I'll say at the rate 0 in X, minus 3 in Y, and 0 in Z. Because there is no movement in Z, there is no movement in X axis, only it is going in the negative direction. So the line will be created. And then I can go for at the rate, no movement in X, no movement in Y, but minus 3 in Z axis. So present. So the YZ plane of the cube is created now. Now if I want to start again from the origin, I say 0, 0, 0. Now I will be using the spherical coordinate system. So if I want to create a line which is parallel to in the x-axis, so I'd say at the rate, the line length is 3, angle is 0 with x-axis, and angle is 0 with the xy plane. So I move this side. Now if I want to go in the z-axis up, so I would say at the rate 3 unit is the length, angle with the x-axis is 0 because there is no angle. This line is 0 degree, and then I'm going to rotate it in the xy plane. So angle with the x-axis is 0, but angle with the xy plane is 90 degree. So now you can see you can change the view cube at this moment of time to see it better. So I'll be using this. Okay. Now I want to go and join this point. So for that, I would say that I'll be using the spherical coordinate system again. So I would say at the rate, the length is 3, but the angle with the x-axis at this moment is 180 degree, because if I would be saying 0, it will go in this direction, but I have to go in the negative x direction. So I'd say angle is 180 degree and the angle with the xy plane is 0. So here I have this face created. Now I would be creating the other face with a cylindrical coordinate system. So here I have the first point. So this first point is 0 in x, 3 in y, and 0 in z. 0, 3, and 0. So now if I want to move in this direction and use a cylindrical coordinate system, I would say at the rate, length is 3 unit, angle with the x-axis is 0 because it is moving in the x-axis, and comma, and the distance from the xy plane is 0 because it is created in the xy plane itself. So we have 0. Now if I want to move up, I would say at the rate, length of the line is 3, angle with the x-axis is 0, but the perpendicular distance from this point in the z-axis is 3 units. So now if you write at the rate 3 angle 0 comma 3, so what is going to happen? Is it going up, or it is basically creating the point somewhere else? So we need to understand the theory of cylindrical coordinate system here. Now what is happening when we said at the rate 3 angle 0 comma 3, so CAD is creating a line of 3 units at an angle of 0 degree with x-axis, and further it is moving perpendicular up 3 units. So the line is coming over here. But at this moment, we require a line which is perpendicular, straight. So in this case, this is a 0 unit line. So here what we need to do is we have to create a line with 0 unit of length at an angle of 0 degree, but the perpendicular distance is 3 units. So this is what exactly the concept is all about. Here, if we want to create a line at this particular point, so with the cylindrical coordinate system, what would be the cylindrical coordinate system for this? So we are going towards 3 units, going towards 3 units in the negative y direction. That means here we are creating a line at this is 0 degree, this is 90, 180, 270. So here we will be saying that create a line of 3 units at an angle of 270 degree at a perpendicular distance of 0. So this line, when it is going towards the negative y direction, is a 270 degree line. Why? So this is the 0 degree line with the x-axis. This is the 90 degree line. This is the 180 degree line, and this is the 270 degree line. So if I say at the rate 3 angle 270, the line will be directed towards this direction. But 270, let us. But now we also need to see how much elevation we are providing to the line. Are we providing any elevation or 0? So it is a 0. So the line is setting over here. I'm sure you will be having difficulties to understand. You have to watch this video again to understand the cylindrical coordinate system. So let me again connect this line. So just click on the views that is suitable to make you understand, or just press on any of the edges, corner points, and just you can have an orbit of it, and now you can see it properly. Now let's say if I want to connect this point, so this point, I would say that line, just pick this point with the object snap, and if I want to go this direction, that is in the x direction, I can use any coordinate system. I can say at the rate 3 units, angle 0 in x, that is I'm using the spherical, and 0 with the xy plane. So this particular cube is created. Now let's again practice some of the shapes with the coordinate system. Now let's say if I am creating a line, the first point is 0, 0, 0. Now if I want to go in the z axis right now with the cylindrical coordinate system, so I have to say that there's a 0 unit of line at an angle of 0 degree, but the distance is 3 units. So I am 3 units up. Now if I want to go, let's say, at the x-axis direction at the rate 3 in x, but the angle with the x-axis is 0 and the angle with the xy plane is 0. So I'm using the spherical coordinate system. Now I want to go up. I am going to create a steps. I want to go again up in the z-axis. So I will say at the rate 0 length, 0 angle, but the unit is 3 units. So I go up. Again, I want to go in the right direction at the rate 3 angle with x-axis is 0, angle with the xy plane is 0. So I have another line. Now if I want to go down, so I have to say at the rate 0 length, angle is 0, but the perpendicular distance is minus 6. 3 plus 3, 6. And then I can go for a close option. So you can see that I have created a step over here, and I'm going to complete the tread over here, the riser and the tread. So I start from this particular point 0, 0, 0, and I want to go in the y direction. So I'm using a relative rectangular coordinate system now. At the rate, so 0 in x, 6 in y, and 0 in z. Now if I want to go in the z direction, so I would say at the rate 0 angle 0, I am using the cylindrical coordinate system, comma 3. Then if I want to go back in the negative y direction over here and close it here, so I would say that this line is 3 units length and angle with the x-axis is 0, 90, 270, 180 and 270. So I would say at the rate 3 angle 270, and if I want to use the uh, spherical coordinate system, I will say angle with the xy plane is 0. So now because it was 3 units, so it ended over here. Now let's say I want to create another feature over here, because I wanted to create a feature, a slot feature over here in the steps. So, or you can further go at the rate, you can write down 0, comma, minus 3, comma, 0. So you can close it. We'll create the slot later on. So now here we again pick the line from this point. I want to go in the x-axis. So I would say at the rate, I can say 3, comma, 0, comma, 0. And here if I want to close it, I would say at the rate 0, comma, minus 3, comma, 0. So relative rectangular system is very easy. Again at the rate minus 3, comma, 0, comma, 0. So here now you see that I have to go at the rate 0, comma, minus 3, comma, 0. So I created one steps here. Further, you can use any number of coordinate systems if you want to create it, but the shortcut is go for a copy option, select the line, let's say this line and this line, and just copy it over here. And here you can basically close these lines and create the step. So here you have to again copy this line, this one and this one, and bring it here so that the 3D wireframe model is created. So 3D wireframe model is a technique which, so I am using a command called 3D orbit, 3DO. So here you can basically orbit the object and see from all the faces. So I'm pressing my mouse, left mouse button, and doing an orbiting. So if I want to join these two lines, which is open from the bottom, so just press escape here, just zoom out, and then you can join these 2 points. Again, you can go with the 3D orbit. 3D orbit is basically orbiting the object to see various faces of it. So this is a 3D model, entirely a 3D model which is having x, y, and z coordinates. So I think the wireframe concept is something that we have understood. Now the next point is I want to create a surface at the face so that the back face is not visible. So it's just like you're creating a wireframe model like the potter do. They create a wireframe and then put a paper to it to create a surface and then make it a solid. So same concept is there. You create a wireframe, create a surface, and then create a solid. So this is the progress of the creation of 3D model, solid modeling. Wireframe, surface, and solid model. So we are going to create a surface into it. So if I put a surface, if I put a paper over it, that means this line will be hidden. So how do I create a surface at the face of a wireframe? So the command is 3D face. So here specify the first point, second point, specify third point, and then you can create a 3-side face right now if I press enter, or specify the fourth point and then press enter. So now if you see that, if you give a command called hide, the object is hidden which is under the face. Now you can see. And then with the visual style, if you go for shaded, you can see that the face is put over here. Now again, this is a visual style. You can have a 2D wireframe. Right now, visual style is 2D wireframe. You can have a hidden option. You can have the conceptual options we'll be discussing later on. And then you have the shaded option. So various options are there. You can try with these options, shades of gray, and a lot of options are there in the visual style. So we are going with the 2D wireframe now, and if I want to hide the surface that is created, I will go for hide option. Now I need to hide this particular face. So I'll go with 3D face again. First, second, third, and then fourth, and press enter. Now again you can test it. You say shade. You can do a 3D orbit, 3DO. You can see how the faces are created. And similarly, you give the faces to the other faces of the wireframe so that a surface can be created from the 3D wireframe. Right click and say exit. Now here in this particular mode, again go to the 2D wireframe. So let's say if I give a 3D face and this particular face, 2, 3, 4, press enter. So you go for a hide option or a shade option. So you can directly go for shade option. Now you can see the faces given over here. So if you want to put, you can also use 3F command for 3D face. 1, 2, 3, 4, the face is created. Now if I want to create a face in this L portion, so I go for 3F. So here we have 1, 2. So if I say third is this point, fourth is this point, so it will be creating a different face. So how would I be creating the face? Let's see. So I have a 3 face. So I go for first, second, and then third point is this, and the fourth is this. So I'll be creating partially here and partially here. Again, I go for a 3 face. 1, 2, 3, 4. Press enter. Similar thing I will be doing here also. So in the 3D orbit, if you look into it, if you right click, there are two views. One is the parallel view, that is the orthographic view, and one is the perspective view, which is a non-parallel view. So I would always prefer to be in the parallel view at the first. So press exit, and then you can have the 2D wireframe again. If you are going for a hide option, so you can always give a hide. You can see that how the faces are hiding the edges. Now similar 3 face, first, second, third, and fourth. Enter. So again hide, again 3 face, first, second, third, and fourth. Hide. So if you want to go for a shade option, shade view, shade. So now again you can go with 3D orbit, and you can see that how the surfaces are created at the face. So this is basically converting the wireframe into a surface. So you can try with more wireframes, and then you can give them an edge as I have done. Let us take some examples of creating more wireframes. Now I'll be teaching you some shortcut ways of creating some wireframes. So let's say if I have, so here I will be using move and copy option also. So let's say I want to go to the top view. So the way to go to the XY plane parallel to the screen is either you go with the click on the view and say top. So this is one way, and the other way I will tell you very soon. So let's say I have a rectangle and rectangle is at the rate 10 comma 10. So size in x and y is 10 comma 10, and I have an offset, let's say 2 units offset, so it comes inside. So here I want to move this rectangle 5 units in the z axis. So I would say move, select, take a base point, and here for the second point I would say at the rate 0 in x, 0 in y, and 5 units in z. So now I have got two rectangles. One is in the xy plane and the other is at a distance of 5 units from the xy plane. Now what I will do is I'll create edges connecting the 4 points of the 4 squares. So I have a truncated pyramid that is created. Now see, sometimes you have to use the view cube to have the correct wireframe modeling. So this is a wedge that I have created, and if I want to create, so I'll just copy it, this rectangle, and now I'm doing a copy option, and I am copying it at the z axis at the rate 0, 0, 3 units. Now what I will be doing is I'm creating another feature. So I just can have the 3D orbit command here so that I can see how things are created. So I'm joining this point. I'm creating a compound object. Now you can see, now I can use the 3D face command to make it a surface. So let's do it. So I have this 3F, 1, 2, 3, and 4. Press enter. So if you hide it, you can see that it is hidden. Or you can go for a shade option to see the shaded part of it. 3F, 1, 2, 3, fourth point. Just go for a 3D O and just rotate it for a particular position. So how do you rotate? Go for 3D O, press the left mouse key and just rotate the cube. So 3 face, 1, 2, 3, 4, 3D face, 1, 2, 3, 4, 3D face, 1, 2, 3, 4, 1, 2, 3, 4, 3D orbit, 3D face, 1, 2, 1, 2, 3, 4. So now you can see, just press undo if you're having some problem with the 3D face. Just rotate the 3D orbit and see if you can correctly click the points. 3D face, 1, 2, 3, 4. So this is how you created a wireframe and then a surface with help of lines and some commands. Now let's do the last example. Now this is the perspective view. In order to change it to a isometric or a parallel view, go for 3D orbit and then change it to the parallel. So just you need to have a lot of practice to create different wireframes. So I'll give you another example and then I will be switching off to the surface tools. And then we will be doing the 3D solid modeling tools and end the session. So now the modeling concepts are getting more and more interesting. Next, move on towards another model that we want to create. Now, again, to come to the top view, just click on the view icon, view control icon, say the top, select all of them, erase it, and then go to the 2D wireframe option. Now I have another rectangle, let's say at the rate 10 comma 10. Just exploding this and creating another 3 units offset. Or what I would say that create a rectangle which is length is 10 units in X and 3 units in Y. So why I am doing so, see, so I'll be moving this rectangle with the base point, and the Z axis would be 0, 0, 5 units. Now let's say if I'm joining this points, I'll be having some different kind of. So now this is another 3D model wireframe that is created. Now let's say we'll be doing more options of this, but once we learn the UCS option, then things will be easier. Okay, now let's erase it. Now come to the topic called surface. Surfaces are basically created with the lines. Now let's take an example. The first surface that we will be doing is a ruled surface. Now what is a ruled surface? So for the ruled surface, you need to have two particular curve. For example, I'm having this. I'm doing it in 2D. So if I am going to join these two arcs, thread it, it will become a surface. So ruled surface, as the name suggests, is basically joining the two curve and create a surface. So if you shade it, you will find that a surface is created. So again, surface is basically created from lines, and solids are created from surface. So the first thing that we are going towards the 3D modeling concept is from line we are going to surface. Now if I want to smooth the surface, I want to create more lines and mesh geometry over here. So before I do a ruled surface, I would be going for a command called surf tab 1, whose value is 6. I would make it 24. Or if I make it 40, so the maximum value that I can have is, so keep on creating. You can have 300, you can have 100. So if you have 1000, so you can create as number of mesh that you can add. So if I go for a rule surf right now, so I select this, so you find that there are 1000 lines which are joining. Previously it was 6. Now let's say if I undo it and give a surf tab value 1 of, let's say, 10. So what will happen if you do a rule surf? So the surface will be having 10 lines. Similarly, if the surf tab value, so after creating the surface with the rule surf, you cannot change the resolution of the surface lines. So if I have 30 and you say rule surf, so 30 lines, so it will be more smoother. So the ruled surface, the surface is ruled by two curves. So let's say if I have one line, let's say if I have a straight line and if I have an arc. So if I want to create a surface joining these two curves, so before creating the surface, we have to see what is the value of surf tab 1. It is 30. So if you say rule surf and then you see the value is surf tab 1 is 30, and then click on this, both the points, the surface will be created. So if you shade it, you will see the surfaces created. Okay. Now if you have now here it is very interesting. Let me have it is into 2D wireframe. Now give you another example of rule surf that I always find very interesting. You have a circle and you have a point at the center. Now p-type, you can command p-type command to change the point style. So if you're moving this, or in the Z axis, you can do it either by the move command, take the point and say at the rate 0, 0, 3. So it moves at the 3 units. It's very high. So let's have a lesser value. Let's create the circle with a greater radius. Let's say the radius is 10 units, so that it is a bigger one. And here I have this point with the Z value at, let's say, 3 units. Now if I say rule surface, I select this circle and this point, a cone will be created. So this is very interesting. When you go to the 3D modeling concepts, you would find a lot of interesting things happening. So rule surface is a surface which is created by two curves, and for that you have the setting called subtab 1. Now again, go to the top view. The next surface command that I would be using is the edge surface. As the rule surface is for two curves, the edge surface creates a surface by four curves which are joined end to end. For example, if I have a line, so I copy this line over here at bottom, and I have an arc which is connected with each other, right? Now I want to create a surface from the four edges of this particular geometry. As such, when the surface will be created, this line will be connected with this, and this line will be knitted with this. So now if you go with the command called edge surf, here you have to set another surface tabulation, that is subtab 2, because subtab 1 is already set to 30. Subtab 2 would be basically the surface tabulation for the second set of curves. The first set of curve will be having 30 units. So let's do surface tabulation 2 and give the value as 30. Now you go with the edge surf command, and here you can select these two curves as the first joining curve. Now select object 3 for surface edge. Now look into this. This surface is created with the help of the four edges. Now if you shade and you have normal shading, the surface will be created. So now you have understood that the surfaces are created with the help of the lines and are joined by surface tabulations. So we'll do another example of edge surf, and then we will go to the another set of commands in solid modeling. So here actually in the 3D modeling for civil engineering and architecture, the main emphasis would be on solid modeling. So the next concepts set of tools that I will be teaching you is about solid modeling and how we can create architectural models or civil models, civil related models more proficiently for our project. So this is a concept that I am going through it, and then I will be taking the momentum and explain you regarding the application of the 3D modeling concepts into the project. So coming back to the topic, so you have this another, let's say we have spline, which is a smooth polyline I'm using for the first time right now. So smooth polyline is just like a curve. Now you have another set of spline, which is a smooth polyline, and then you have to join the edges one to one. Let's say I have another smooth polyline, which is here, and then another set of smooth polyline here. Now remember, the edge surf will only command will only work if the edges are connected with each other. Otherwise, it will not work. So we have the command called edgesurf, and you need to see that surf tab 1 is 30 and surf tab 2 is 30. 1 and 2, 3 and 4. The surface is generated. So the more surface tabulation you require, the more value you have to give. So you can give with the 3D orbit command and you can see the surface is generated. So here what you can do is go with the shade and see how the surface is generated. The next command in the surfaces is our rule surf. We have done the edge surf. Now we will be doing the rev surf. So this is again a very interesting concept which will be further used in solid modeling, which is a surface which is created by revolving a line or a curve within an axis. So for example, if I have an arc, so let's take an example of a arc, start point and end point at the bottom, second point let's say here, and this is an arc, and there is a line, straight line, which is an axis. So what will happen? Imagine what will happen if I revolve this arc within this axis. Can you imagine? Okay, so a curve will be generated with the profile of this arc. So again, for rev surf is surface created with the revolution of an arc over an axis. So again, surf tab 1 is 30, surf tab 2 is 30. You have to look into it and then select object to revolve. So this is the object that we want to revolve. Select object that defines the axis of revolution. So remember that the object should be a line for the axis. So I select this and now it says start angle, I say 0 and the end angle is 360 degrees. Now you can shade it and see how it looks like. So let's take more example with other parameters. Now let me go back to the top view and let me copy three copies of this particular curve with different options I will be showing. Now rev surf command, give it in the command prompt, select it, select the object that defines the axis of revolution, start angle is 0, end angle is 360. So this is a curve that is generated, surface that is generated. Rev surf, object to revolve, axis, start angle 0 and the end angle is 180 degree. This is a surface that is generated. Rev surf, object, start angle is 90 degree and the end angle is 180 degree, included angle. So this is how you generate revolved surfaces from curves. Now let's take another example. You have a circle and you have an axis. So if you revolve this surface, what will happen? So circle, axis. So this is the refsurf command, select axis, angle 0 and include angle is 180 degree. A tube-like structure will be formed. So if you want to shade it, you can see it. You want to give a color to it, you can always give a color to it. Go to the properties and give some color. If you want to see it smooth in conceptual, you can see. So this is how the revolved surface command works. You can create domes, you can create sphere. So now what happens if the axis, I'm just undoing it, if the axis passes through the center, let's try it. So we have the surface command, select the axis of revolution and 360 degree, a sphere will be created. So this is how uh, you can try with various kind of options and use the ref circle. Next, going to the next set of surface tools. I hope you will be enjoying it while you do it. And then we have the, go to the top. The next is basically the tab surface. Now the tab surf command. So this is called a tabulated surface, not surface tabulation, tabulated surface. Now how it works, if you have an arc and there is a line which is a perpendicular vector going in the z axis, so you can do it by direct entry, just clicking the z axis, go through it, in the ortho you can go in x, y and in z. So let's say I'm going in the z direction. Now this is a direction vector. Now if you want this arc to basically go up and create a surface in this direction vector, you can use the command called tab surf. Select object for path. So this is the object and this is the direction vector. So a surface will be created in the direction vector. So this is the tab surf. Here the sub tab 1 value is taken. So this ends the basic of surfaces. Before we go to learn about the solid modeling tools in this session. So you can have these tools that I have taught you in the mesh tab, and these are the tools like you have the rule surf, tabulated surface and the edge surf. Now let's go to the solid modeling tool. Now next part, it is very important to understand what is a solid model. Solid models are basically 3D solid objects which is having mass properties. So the difference between a surface model, the wireframe model and the solid model is, the solid model is having mass. That means it is the whole stuff of object which is inside, which is a solid. So any model that we'll be creating over here with the solid modeling tools will be having the mass into it. So we'll be seeing how we are creating. So first of all, let's understand the basic primitives of the solid models. The basic primitives are the boxes, how to create a box, cylinder, sphere, and then we will be learning some 3D modeling tools like the extrude, the revolve, sweep, and then we will be also in the sweep we have got sweep and loft, and then we will be having some Boolean operations like union, subtract, intersect, and then we will be learning about how to slice an object, 3D object. Then we will be learning about how to fillet, taper and create shell, and there are a lot of other options that we'll be learning. And then we will be learning about how to create practical objects, different objects like wall, doors, windows, staircases, columns, beams. How can they be created in our project? So now the next couple of hours or next hour we'll be discussing about various concepts of 3D modeling, and here also I will be taking the concept of UCS, user coordinate system, and how we can use. First, let us quickly have the tour of basic solid objects, and then we will be looking into the other tools. So box. So if you want to create a box, creates a 3D solid box. Give the first corner of the box, first corner, other corner, create a rectangle, and then give a length. So you have the other corner, and then give the height. So if you want to give a height of, let's say, if you just click it, the box will be created. Now, this box is completely solid object. Now, if you use a command called mass property, if you click into it, you will have the entire mass property like the centroid, the moment of inertia, and the volume of the box and the mass, taking the density as well. So similarly, if you want to create, now let's go up, escaping it, and create a box again and see the various tools. Box is the command. So you can create a box from the center, specify the center of the box, specify the corner of the box. Let's say you want to give some corner point and the height. Again, the height is from the center. So we'll be doing it by certain values. Let's create a box first. First corner point, just click it somewhere here. At the rate, let's say other corner point is 10, 10, and the height that I would be giving is, let's say, 10 units. So here I would say other corner point at the rate 10, 10, because that's what the other corner point is, and the height, so I would be giving as 10. So a box is created, a cube is created 10 in 10 length, width, and height. So again, let's go with the box. First corner point and other is 5, 10, and the height I'm giving as 5 units. So a cuboid is created now. Now, if you want to create a box from the center, so center option, click into it, and now you can see the creation is from the center. You can have a length option. Length of the box is, let's say, 10 units, width is 10 units, and the height is 5 units. So the box is created from the center. The point that you click is the center of the box. So you can try with the other options. Coming to a cylinder will be requiring a center point, like specify center point. So I click over here, the radius of the cylinder, I would suggest that I give it a 5 unit, and then there are various options, 2 points and axis endpoint. Now these are very important points. So if I only specify the heights, so I say height is 5 units, so cylinder is created. Now if you go into the property of the cylinder, you will find that the radius and height is given. You can change the height. Let's say I want to change the height to 10. The cylinder will be increased. Now here another thing that you see here is the grips are created. So with the grips you can increase the height, decrease the height, whatever you want you can do. So again, if you look into the properties, there is an option called solid history. You can record the solid history, show history. Yes. So we will show the history. So if you go with the solid history, select it into the value solid history 1. So with the mask property, you can see the value of the solid. So here I have gone here with the properties option, and then if I want to create an elliptical cylinder, so here you can have the major axis. Now you can give it as 20. So a elliptical kind of cylinder is created. So if you want to create an elliptical cylinder, you can go to the top. You can go for the cylinder command. You can say elliptical, create the ellipse endpoint, the other endpoint, and specify endpoint of the second axis. So you have this base created, and by 2 points you give the height. Now let's say the height would be somewhat like this, like the 2 points you give. This is the distance, the height. So you can see that a cylinder is created of that particular height. Now again, let me do it again to show you the 2-point option. So I'm creating a center of the cylinder, radius I'm giving, and with the 2 point I am specifying that the height would be this much high, 4 units. So this height of the cylinder will be taken from the 2 point that I have given. So again, you can create a cylinder with 3 point, 2 point, TTR and other circle option. You can try with this. Sphere will be having a center point, again the radius, let's say 10 units. Now over here, if you are creating a cylinder that's a curved surface right now, you will see that if you do a hide operation, the meshes are not smooth, right? To make the meshes smooth in the hide operation for the curve solids, you have a command called face stress, face resolution. So the maximum value is 10. Now if you do a regenerate command and then you go for a hide option, you can see the surface resolution of the solid object changes, both for the cylinder and the sphere. Now if the face stress command is, let's say, 1, now if you say hide, you can see the surface is not so smooth. So even if you shade it or see in the realistic, you can see the smoothness is not so achieved. So for that you have to go with face stress command. The maximum value is 10, and then you can see. So now here in the hidden, the surfaces would not be seen, but in the wireframe the surface resolution can be seen. Go for the height. The moment you zoom, it will be gone. Okay, so this is the sphere, and you can try several options for sphere. Now here you can increase with the grips, decrease with the grips. So friends, this was the option for basic primitive solids that you could do. Sorry. So there is something called polysolid. So here we have more solids over here, and let's try with this one. The first thing is the polysolid. Specify start point of the polysolid. So you specify the start point, and then the next point, you can see that a wall type structure is created over here. So it means that it is having a thickness. So if you create a polysolid, here you have the width. You can set the width. Let's say I set the width to 0.5 and height to, let's say, 3 units. So now if I start this point, 0.5 height, 0.5 width and 4 unit height of solid will be created. Now this is entirely a 3D solid. So if you shade, you can give the shade command to shade, or if you hide, you can see that the 3D model is generated. Now what else I can do with this polysolid? Go to the top and go to the 2D wireframe option. So in the polysolid, if you want to set the height and width, that is fine, and you can select an object. For example, if you have a arc and if you want to convert it into a polysolid, that is a curved wall example, so you take a polysolid, you take a width, you take a height, and then select this arc, a polysolid will be generated. Now if you go for height command and if you increase the face stress command value, now it is maximum is 10, it will not go beyond 10. So if I say 15, it is not taking. So you can see this particular ball-like structure is generated. So let us go to the top view again. So this is about the polysolid, and then we have this wedge option. Wedge option is just like a box which is cut. So you have the first corner point, so all the commands will be same as the box, other corner point, and if you get the height, a wedge will be created. You can go with the command prompt. Let's say, for example, go for a wedge. First corner point, let's say I give at the rate 10 comma 10, and the height I give as a 10 unit. So a bigger wedge will be created. So this is something that you can consider. Next is the cone. For the cone, you have again like a cylinder, the cone works. The only difference it would be meeting at a point. So center of the cone, the base radius of the cone is 3 units. Height of the cone is, let's say, 5 units. A cone is set. Now if I want a truncated cone, so I have a cone over here. Take a cone option. Center point, radius is 5 units. And I want the top radius to be, let's say, 2.5 units, and the height I give it as 10 units. So I can see a truncated cone created with the help of the cone option. So other options are very similar to what we have learned. So now one of the very interesting option over here is the axis endpoint. Now if I want to have the axis at this particular, in the Z, the cone will be created. But if I want to have a cone which is lying on the ground, so I can give the axis endpoint in the x-axis. Now you can see the cone is lying in the xy plane. So this is what I can have a different option in cone. Next is the pyramid. So specify center of base or edge or sides. So let's go with the center point of base. So center point is this, and this is the base radius. So let's say if I give the base radius as 5 units, and you have the height as 5 units. A pyramid. So now you can see that if I use the distance command, this particular length is 10 because the base radius was 5 units. So the length is 10, and the height is given what we have decided. So let's go again and say the command pyramid, or go the pyramid way. Center point, or you can go with the edges. So if you want the first edge point here and the second edge point at, let's say, 10 comma 0 in the x-axis, and now if you want to give a height of 5 units, so a pyramid of 10 units edge of, so now you can see, and height of 5 units will be created. Now let's go for more options in pyramid. So in pyramid there is another option called the sides option, where you can create a polygon kind of thing. Hexagon, you can have a center of the hexagon. Again, you can create inscribed or circumscribed. So the base radius is something, the distance from the center point to the perpendicular to the edge, let's say it is 5 units, and you have the height. So hexagonal pyramid is created. So you can have pyramids of base geometry of different sides. You can have pyramids of base geometry of different sides. For example, now let's say if I take a pyramid and if I go with edges, first point, and because the side we have taken, and the second point at this point, and the height I can give. Now let's say if I want to have a truncated pyramid, like we had a truncated cone, let's say I go for the pyramid option. So I go with the edge option. So I take this one, and here I go with the top radius and give a top radius value, let's say 5 units. Now you can see that. So, and the height, now I have to give the height, let's say 10 units. So a truncated kind of pyramid is created. Now let's go with some values. So I have a edge option. I can go with the edge option, the first point at the rate 5, 0 in x-axis. Now let's say if I go with the top radius of 5 units and the height, or I can give of 10 units. So I have got a pyramid of this shape. Now let's take some example with this square edge. So I go with the pyramid and the center, let's say I go with sides 4 now, and the center point is this, and the base radius is, let's say I give it as 10 units, and for the top base radius I give it as 5 units, and the height I want to give, let's say 5 units. So you can see that this truncated pyramid is created. So you can also have a pyramid lying down in the xy plane. Like for example, if I want to create a pyramid with center point of base here, base radius as 5 units, and if I want to give the axis endpoint here, so it is lying on the xy plane. So this basically shows how we can create the pyramid with different options. You can try with all other options, and definitely you will be able to create pyramids. So now let's do with the last option called the torus. Torus is like a tube, like center point of the torus, the radius of the torus, like a tube radius. Let's say I have a radius of 10 units, and the tube radius that I want to give it as 1 unit. So now you can see a tube of 1 unit radius is created with the help of the torus command. So this is the torus. So let's create the torus again. So command for torus is torus. So you can create by 3 point, 2 point, TTR, whatever options you can. You can give the diameter. Diameter of the torus is 20 units. And the tube radius, let's say, tube diameter is, let's say, 5 units. So a torus is created. So here we have done some basic primitive. Now let's talk about custom creation of 3D solids. So the creation of 3D solids custom base starts from some commands. We start with the extrude, revolve, then we go to the press pull tool, then we go with the sweep and the loft, and then we will be doing all these options series. We will be having the fillet edges, how the fillet and chamfer can be done. In the 3D, how we can taper the surface, how we can extrude a surface, and then how the shell can be done. So there are a lot of tools that we'll be learning in the 3D modeling concept, and we'll be doing a particular model of a building element. Now, let's say if you have a profile, if you have a circle. Now I'm having two options. I have a closed edge. These are the profiles, and I am all creating this in the XY plane. So I have a circle and I have a line like this, and I trim it. Now, these are all wireframe objects, 2D objects. I want to extrude this circle. I want to make the solid of the circle as such. If I extrude it in the z-axis, a solid will be created. Now, here, to extrude a wireframe object, it should be closed and it should have a region. The first step is to, if I want to extrude the 3D object, the 2D object in the z-axis, I have to make a closed region. The first thing is that to make it a region, select this object, a region is created. So region is just like a surface created before you are creating a solid. So this is the surface. So if I want to extrude this particular closed surface, I have to make the region of it, and make sure that to create a region, it has to be a closed entity. For example, if this is an object which is like this, the endpoints are not closed, regions will not be created. So you have to basically have a closed entity. So region select. Now I have got 3 regions, and now I have this extrude option. Select object to extrude. So here I select this object, enter, and then I have got different options. First is the height of extrusion. So I give the height of extrusion 5 units. Ext is the command. Select this object, enter, and the height of extrusion is 4 units. Ext is the option. Select it, height of extrusion is 5 units. So you can see that different objects are created from different regions. So now I will be also telling you other way of creating a region and then creating a solid. So now I will be jumping towards some practical examples. So let's say I have, first of all, I would like to make this as a top view and have the visual style as 2D wireframe. Now let's say I have a line like this. I want to extract the closed portion as a region and then extrude it. So for that, I cannot use the region command, but there's a command called boundary. Boundary is just like a hatch. So if you say the object type is a region and pick a point inside, this object, the closed entity inside will be identified as a region and it will be created. Now, if you want to extrude it, you can give a value, height of extrusion 10 units. Now you see that if you move this object, the original profile will be there. The only thing is that the region is extracted from the closed loop. Now let me give you another example. If you have a circle and let's say if you have some profile like this. Now you go for a boundary option, pick a point and select this. See, the region is created from the closed loop. Now if you extrude this object, you can see that the profile remains where it was and the region is created separately and the object is extruded. So boundary option is another very interesting option that we use while we are working in a particular project. So we will be using it regularly, the boundary option. Now, another thing is that, so in extrude, there are various other options. So if I have a circle, if I go with an extrude, so there is an option called taper angle. There's an option called path and there's an option called direction. So let's take with the direction. Direction we have done. Let's say start point of the extrusion is this and I want to extrude this object in this direction. So extrude direction is parallel to the plane of sweep curve, so it is not working. So in this case, if I would have the direction in the z axis, the object could have been created. So we'll be talking about more application of the direction, how the direction will matter. So it has to be an inclined line parallel to the x axis or xy plane and inclined to the xy. Now let us take an example. If I want to explain you the direction option, there is a circle. There is a line which is at an angle of 0 degree with the x-axis but 45 degree with the xy plane. So how do we do with the polar coordinate system? The line is 10 units length, angle with the x-axis is 0 and angle with the xy plane is 45 degree. So this is inclined to the XY plane. Now I want to extrude this particular circle with a in this direction. Now let's do it. Extrude. Now we have this object. I have to create a region, or for circle I don't require actually. So extrude, select the object. Okay, the direction, the start point is this and the end point is somewhere here. So you can see that how the circle is extruded in the direction mentioned by me. The next option in the extrusion is the taper angle. Now let's say if I have a circle of radius of let's say 5 units. Now let me copy this circle to give you the example. Now if I'll make these two circles a region, I am extruding this circle at a height of 10 units with zero tapering. Tapering means I am tapering the faces with the Z axis, but here the angle is 0 degree. Now if I want to have a taper angle of 10 degree with the Z axis and the height is same, so go with the extrude option, select the object, so go with the extrude option, select the object and then go for the taper angle. Now this taper angle is the angle that the solid will make, the faces of the solid will make with the Z axis. For example, it is 15 degree angle and the height that you are giving is let's say 5 units. Now you can see that the faces of this particular extrusion is at an angle specified by the user, that is 15 degree. Now let's take an example of a, so let me go with the shaded and 2D wireframe option and go to the 3D orbit and make it parallel. Okay, now let's say if I have, so let me again bring back the shaded option. I have a rectangle. So here I go with extrude. So I'm not giving a height, I'm giving a taper angle of 15 degree and height now I'll be given as 10. So you can see it is taper. Now let's take a custom geometry. Let's say if I have a circle like this, go for a boundary option, select it, extrude. Now if I directly extrude the taper angle of 0, so but I want a taper angle let's say of 15 degree at an height of let's say 10 units. So the faces will be tapering from the curved as well as the flat surface. So this is the utility of taper angle in AutoCAD 3. Now let me tell you one particular option that we have used in 2D, that is a polyline. Now let's say if I have a polyline and if I want to make the polyline in the Z axis, this polyline will not go to Z axis because this polyline is a polyline which is only applicable in the 2D axis. It will not go into the Z axis. You only have it in the X and Y axis. But now let's say, but it is a single object. If I want to create a 3D polyline, the command is 3p. Now this is very interesting. Now you have a 3p command. Now let's say this polyline can go in any axis that you want to go. Now, since this is the polyline that it can go at any axis, you can utilize this for the next command called the extrude by path. Now let's say if I have a polyline which is going straight first, a 3D polyline which is going straight. Let's say you can see the length, it's 68, and then coming down and here. Now if I create a circle here, make it a region, rather than extruding this circle in direction or in taper path, taper angle, I select the option called path. So I have to select a path which is perpendicular to this profile. So you can see this path is perpendicular to this profile. So if I select this circle will be extruded in the path. Let me give another example. You have a rectangle. I put a cut over here in a rectangle, let's say here, and I create a boundary region from this particular point. Just place this region at the tip of this polyline, right? Just move it, 3D polyline, and then extrude, and use the option, select the region, path. You can see that this object will be extruded along the path. So this way you can create a lot of features like the profile features of the columns, of girders, and then a lot of things, and let's say door frame you can create. So we'll be using this extrude by path in a bigger way. So the extrusion command is basically extruding an object in z axis with a. So for an extrusion you require a profile, you require height, path, direction, or taper angle. So this was extrusion. So we will be doing more of extrusion later in this session. Next is basically the revolve. Now you have done the revolve option in the surface. Now let us do it in the solid. Now let's get the 2D wireframe and the top activated. So you have let's say an arc, and here you have this feature. Now to revolve this particular feature in a particular axis, so for revolve you need a region, closed region. But if you revolve an arc, it will be a surface, but you need a region to revolve. So if you revolve a region, it will be a solid revolve. So revolve command is for the solid. It will ask you to select the region. So for that you need to create a region. So reg is the command. Create a region. And then if you shade it, you will find that the region is created. Go with the revolve command, reb. Select the object to revolve. Select the object to revolve. So you have selected, press enter. Now you have got options. Start point of define axis by point. So this is the axis that you're defining, and then angle of revolution. So if you say 180 degree, the object will be revolved at an angle of 180 degree. So similarly, you find there are other options in the revolve tool, like the start angle. So if you define the axis, it will say what is the start angle. So if you say start angle, it has 90 degree, and you end the angle of revolution. If you say it is 180 degree, it will create a revolve profile starting from 90 degree to 180 degree. So this is a revolve option. Now you can always go for the 3D orbit to look into it. Now in the 3D orbit, one feature I am talking about is the visual styles. You can have in different visual styles. You can check with all the visual style. And then there is something called continuous revolving. So here we can go with the visual aids. There are uses icon, grids, and other thing. And then okay, in the other navigation mode, there is an option called continuous orbit. So if you just click it, it will keep on revolving in continuously. So if you have something that you want to see in the space, you can always use a continuous orbit. So you can go here now, go to the 2D wireframe, go to the top, and let's create more revolve feature. Now let's say if I want to create a, so we'll be doing more tools in revolve. Let's say if I create a feature like this. So now let's see how the revolve will create. So for this, I have to create a region either by the boundary command or region command. Let's say I have this axis here. So I want to create a revolve with this region and this axis. Next, I want to create the axis here. So there are two options that I'm going to check. REV, select. So here I can select the axis by object. So I can select this object. So this will become the axis of revolution, and the angle of revolution I can have it at 90 degrees. Similarly, I can use the revolve command, select it. Now if it says I want the x-axis to be the axis of revolution. Now what will happen if I say x-axis? It's very interesting. So let's say if I have the y-axis, so if I take y-axis, the object will revolve along the y-axis. So it will take the y-axis as the axis of revolution. Similarly, if you take x-axis, it will take x-axis as the axis of revolution. So now if you revolve and say object, so you can select this object. So this object will revolve in this particular axis. So again, you can go with the shade option, 3D orbit, and you can check it how it happens. Now next, after the revolve option, we will be doing sweep and loft. Quickly, we will be taking these tools, and then I will be teaching you the Boolean tools and ending the session. And the next session, I will be taking some practical examples. So, the sweep and the loft. Sweep and the loft are two tools which are created or which are used to create 3D solids out of cross sections and out of paths. Give you an example. Sweep means that if any solid is created from a profile in a particular path, then that solid is a sweep solid. So let's take an example. If I have a circle, now we have done extrude by path, but in extrude by path, the path has to be in perpendicular axis. Now let's say I have a circle, circular region, I create a region, and then I have an arc. Let's say create an arc. Typical examples I will be giving, and then we will be doing some kind of so I do an arc with let's say center of the arc, and let's say I create an arc like this. Now let's say here I want that the circle should sweep the arc and create a solid. That means the cross section of this particular arc should be a circular shape. So here I go with the sweep option, select the object to sweep, I select this and press enter, and here I will be having the sweep path. So here I can see that the circle jumps to the start point, create a profile over here, and then creates a surface, create a solid. So this is a 3D solid. So if you go for a mask property, it will be having a mask property. Okay, the volume is given. So let's take some more example. So let's say if I have a circle, let me trim this. Let me have an offset. I have a boundary. I create a region from here. Now shade it. Now I want to have this particular profile sweep in this arc. So I'll go with the sweep option here. Select this, enter, and this is the path. Now you can see that this particular shape is created. This can be a roof, this can be any structure that I would can go. Let us take an example of a cross section of a bridge, or a, let's say I want to have a bridge profile at this particular, or a road profile at this particular. This is the alignment of the road. So let's say if the road is somewhat, I'm not having a very exact kind of profile. Let's say this is the profile of a 2-lane road. Let's say, so this is a divider here, the median, and so what I will be doing is I would be exploding this and then later on joining. So I mirror this particular line, not selecting this one. So this is something, the profile that I would be looking forward for, let's say, and then I'll be creating a region out of it. So I can trim it. I can create a region by the region command or the boundary command. Let's say I'll be using the boundary command. So let's say I have this boundary command. So now it says specify a point. So this is fine. So now if you shade it here, now if you say sweep, select this object, select this path. So select this object that you want to sweep, select the path. You can see that the object is swept, but the alignment is at the bottom. Now we can have different settings over here. Now if I go for a sweep option, this is an object that I'm going to sweep, and then I can have the base point, the scale, the twist, and the alignment. So we will be doing this one by one. Now let's say if I want to have this object, the region, and the path is this, but I want to make this perpendicular to this particular profile. So here I go for an alignment, align sweep object perpendicular to the path. Before sweep I say yes, and now select the path, and you can see that the profile becomes perpendicular and the 2 lanes are visible. Similarly, if you want to have, now if you are sweeping this object, you select this sweep, and let's say go for the alignment. So what is happening, once you sweep it, the object is aligned at the midpoint. So the midpoint of this profile is aligning with the arc, and half of it is here and half of it here. Now if I want to sweep this particular profile, let's say I select this, and I want to have the base point, I want to have this point sweep at this particular arc, and the entire section moves inside. So I change the base point to this particular point. Select the sweep path. Now you can see that the point has moved inside and the sweep is taken from the outer corner. So this is the base point option of the sweep. The next is, let's say if I have a circle. Now I select this object and there's a scale option. So if I want to increase the scale twice, so you can see that the circle is increasing 2 times at the end. So this is a sweep that is created with the scale option. That means when it is sweeping, the algorithm reads to the end point and it becomes twice the size it was there in the start point. So here I can have, let's say, a rectangle, and let's say I go for a sweep, select it, and I say scale, and here I give the scale factor as 0.5 and select the path. So the object will be scaled half at the end. So this is way. Now you can see that a ramp-like structure is created. So there are a lot of applications would be there. Now if you look into the front view of it, so it is scaling uniformly and it is getting half size when it goes to the endpoint. So again, so there are a lot of good applications in 3D. So now let's go with some more sweep option. One more is left. Let's say if I have an arc. So now let's go with the 2D polyline. Let's say if I have a polyline, right? I explode it. I have a fillet of radius 10 at the edge. So I think radius 10 is too much. So radius 2 I take. Okay. And then I join to make it a single path. So here I go with a circle. Let's say dia is 1 unit. So if I have a sweep and select the object to sweep and the path, and before that I go for a twist angle, and let's say enter twist angle or allow banking for a non-linear planar sweep. So twist angle is, let's say, 5 degree. Now what will happen is the circle, the object will twist. Now 5 degree is less, so let's give some twisting angle greater than 360 degree, or if I give 360 degree as an angle, now you see what will happen. So twist angle, let's say if I give 360 degree, so the object will twist. So you can see if you shade it, the meshes will twist, or if I give more value to the circle, let's say 1. So we have a sweep, select the object to sweep, take a path and say twist angle is, let's say, 1050, sweep path. So the twist would be basically depending upon how much knurling that I have. Now to see the twist happening, I take a rectangle. So I go with sweep because circle, the twist is not so valid. So I have the sweep path. So before that I have a twist of 360 degree, let's say. So I select this angle of 360 degree. press enter, select the sweep path. Now I can see that this particular section has been twisted. So you can try with various sections, and you will understand the reason why twist is done. So now, so after doing the, let me erase this, go to the top. The next option is the loft. So as you have done the sweep option, the loft is similar to the sweep option, but it is in a different concept. Let us first of all revise the sweep option. So if we were doing a rectangle sweep, at least the twist option. So we have this sweep, select the twist option, let's say 360-degree twist, the path, the object get twisted. So you can have the shaded portion on, and you can see that how the twisting is done. So this is the uh, sweep option that we have discussed. Now the next we would be talking about the loft option. So loft is basically a command that is used to create a solid from cross section. Now let's imagine that you have a circle, and you have got multiple circles inside in a XY plane. Let's move this circle. So we will be having some practical examples with the loft later on. So now if you want to create surface, not a surface in fact, 3D solid from these three cross sections, then we should go for loft. So to create a region of all of them, so go for a loft, select the cross section first, second, and the third. Now you can see that beautiful 3D lofted object is created. There are several options. We can use them later on when we'll be doing some of the practical approaches. But here you need to understand the difference between. Now there are various grips are developed. Like for example, if you click any of them, there are various options. You can try like the position G0, G1, curvature G2. So you can have different. So you can have a draft angle, you know. So you can go with different kind of curve sections, uh, bulginess that you can have in the loft section. So coming back to it, the loft section is created. So if I want to have the loft, cross section 1, 2, 3, from different cross section, press enter and press enter to finish it. From different types of cross section in a particular axis or a particular direction. So we'll be talking more about it in some of the uh, process when we'll be doing in further sessions. But so this is the loft option because I wanted to tell the difference between loft and sweep is basically a command that creates a solid of a cross section along a path, but loft is basically created for the cross sections. A lot of cross sections are there. So it be, and then from the cross section a solid surface is created. A solid is created. Okay. Now that next thing is that the press pull. Now the press pull tool is something that create a region. So if you have a press pull tool, so you can press it, select any of the bounding area and pull it. So this is the press pull tool. So if you have a now if you are using a press pull tool, you can select any surface and pull them and press them and pull them. So this is the press pull tool that you can use in 3D modeling. Now coming to the next set of commands that are used while we are working in 3D modeling. So these set of commands are the union, subtract, intersect. And then we will be doing certain commands that will be helping you to create some objects in 3D space. So let's do that. First of all, union. So union is, let's start it from the basic concepts in the region. So let's say, then we will go to the solid. Let's say I have got two rectangles, one and another is two. So I have created these two rectangles in two regions. Now you can see if you shade it, you can see. Similarly, I have got two solids of this rectangle. The second one I extrude, and the previous one I keep it without extruding. Now if I do a union command, this is a Boolean operation. So if I select these two regions, these two regions will become a one region, and then I can extrude it. I can press pull it and make it a extrusion. Now these two solids are created, but I want to union it. After doing the union, these two objects will become a single object. So union is basically combining two regions to form one region, or combining two solid to become one solid. So let's take an example of a circle and a rectangle. So if I do a region of these two and make a union of this region, so this will become a single object. So when I extrude it, this will be extruded together. Similarly, if I have a rectangle and a circle with 2 points, and if I do a region, extrude them individually, and then make a union of it, the compound object of these two will be created into a single object, and this will be a single object. So union is basically uniting two surfaces or two regions or two solid to be one surface, region, or a solid. Next Boolean operation is, so I can go to the 2D plan, is the subtract. So what we do in the subtract, we have the two regions. Let's say I have a rectangle and I have a circle. Now here, let's say I do a region, go for the shade option. Now if I subtract, this is the rectangle and circle from the rectangle, a cut will be there. Similarly, let's take an example where I copy these two objects. I go with the circle over here and just put it here. I subtract the circle from the rectangle, so a general cut will be there. Similarly, so you can see that after doing the subtraction, this object will be a single object from the region. And similarly, if I go with the extrusion of both of them and then I subtract the box, the cylinder from the box, so a hole will be created. So subtraction is basically getting the mass out of a solid object, subtracting one object from the other. In this case, it was the cylinder from the box. So this is the subtract operation. And the third operation is the intersect, where let's say we have got two regions and I would like to do an intersect option. So intersect option is basically finding out the common portion of the two objects where the common is. So it's basically a set operation theory, Boolean, union, subtract, and intersect. Now let's do it quickly and understand all the three options over here. So in the next part here, after this, we will be doing the UCS option, and then I will give you some uh, demonstration of how to create a particular object. And then in the next session, we'll be doing about the solid editing tools and like fillet and taper and other options. Now let's go with the union operation. So union operation, if you have two solids, let's say if I have a box, if I have a cylinder, these are all solid object. Remember, it should be two solids. So if I do a union, this will be created into one object. Similarly, if I have two regions, so I have two regions created. So if I do a union, it will be into a single entity, and then I can extrude it. If I have three regions and I subtract the smaller circle from the bigger one. So first I have to subtract the object from which I'm going to subtract the bigger one, and then press enter, and then select the object that I want to subtract. So if you do a shading, you will find that the cut is there, and then you can extrude it. Again, let's say if you have a circle, you extrude it now. If I have another circle, I extrude it, and now I want to subtract the smaller circle from the smaller cylinder from the bigger cylinder. So select the bigger cylinder first, the smaller one, and then you have the subtract option. And the intersect, if I want to do the intersection here, so select both of them and the intersection will be there. Now here we have done most of the tools in the 3D solid modeling. So let's do some practical examples. So in doing this example, I would be also taking the UCS session. But before that, just give you an example of what UCS is. Now, for example, if I have a rectangle, I create a box and I want to create a circle, extrude it backward and create a hole of it. So I have to create the circle in this space. So the UCS command basically allows me to select a face where I want to work. So again, UCS is basically user coordinate system. And if you want to sketch something, if you want to do 2D features, you have to have the XY plane. For example, now if you look into it, currently the XY plane is at the bottom. So whatever I am creating, it has been created at the bottom. For the UCS, there are various commands. So one of the command is UCS, by which you select the UCS. And then there is another command called UCS manager. And there is another command called UCS icon. The first thing that we'll be doing is the UCS icon. So if the UCS icon basically changes the visibility of and the properties of the UCS icon. For example, if I'm switching it off, I can do it from here also, on and off, UCS icon. Now, if I want to, you can see the UCS icon is on. Press UCS icon again. So you can put it on and off, properties. Now you can have this icon style. You can change the color. You can change the size. So now you can see it is having something different properties. So UCS icon is dedicated to the change of property and visibility of the UCS icon. So I go to the UCS icon, I take the 3D and increase the line size. That's good. So now, other thing is that if you want to do this from the ribbon, so there are a bunch of tools over here, and apart from that, you can also save the UCS. So you can have named UCS. We will be talking now about it. But before that, let's say I want to create a circle and in this face of the solid, extrude it and subtract it from the solid, this box. So for that, I will go with the UCS option, and then I will be just going with the first option, changing the origin, change the X here and change the Y here. Now what has happened is the XY is in the face of this particular box. I will change, I'll create a circle over here, create a region here, and let's say I will go for an extrude and I will extrude a bit into the half. Let's say. Now if I want to subtract this, so if you look into it, the object is subtract. Now let us take another example where I want to change my UCS over here. Now what happened when I changed my UCS over here in this particular face? The origin has moved to the point. If you look into the origin, if you can test the origin, see the origin is over here. Now if you want the UCS back to its default position, so you can always go for UCS command and go for W option. You can also have these options from here. If you check it over here, UCS icon properties, UCS. So same UCS command you can invoke from here. Then this is the UCS name UCS. This is the UCS world. So UCS world is the default position of the UCS. And then now if you want to change this UCS into this face, so you can have various options like UCS. You can have the option called face option. So if you select this face over here, that will ask you X flip and Y flip. So if you do X flip, the X, now you can see the Y axis is flipping in the X axis, along the X axis. So the direction of the Y changes, and according to the thumb rule, the Z axis is changing its direction. Now let's say if I do a Y flip, so the X, again you can see the Z axis is changing its direction. So let me keep the X in this direction, Y and Z in this direction. Press enter to accept. So now if you create something, you can, if you create a circle again, it will be created in this. Now, if you want to create a cut inside, you have to go negative Z. So I would go for minus 10. So it is cutting through. Minus 10 is huge. So you can go for a subtract. It will cut the hole through. So how do I go subtract? Subtract, select object this box, and this cylinder is the another one. So you can see that if you shade with the shade tool, it is cutting through. So next is okay. So again, to know the UCS better, so let me have more options of the UCS. So let me go to the UCS world because that's what the default position is. So I have this rectangle. I extrude this rectangle up. And let's say if I want to create another, I want to go for UCS and I'm using the option called, let's say, the Z axis, or I can have the various option, but I have taught you faced. Now you will be learning about X, Y, Z and axis. Now let's say if I have the X axis option, for that I would like that the UCS should be moved into this and have this face here. You can understand it better. Now if I rotate the tripod in the x-axis, the y will rotate and the z will move up. So it's just rotating the tripod in the x-axis. So now see what happens if you say UCS and X as the option. So what it is doing, it is rotating the tripod, keeping the x-axis constant. So now in this case, if you say x-axis, the rotation is 90 degree about its x-axis. So now you can see the y has come down and the z has. Then now the working plane is xy, again the horizontal. So if you want to basically go for x-axis and then if you go for 90 degree, now you can see the working plane is at this face. Now if you want this as the working plane, so you have to make it x and y. So let's say you go with UCS, uh, UCS and you say y-axis. Now if you look into it, if you say y-axis and if you say 90 degree, so this particular face becomes the working plane. So if you want to create something, you can create. So again, this was a situation prior to rotation. So I want to rotate this ZX along the y-axis. So here the Z will be here and the X will go in this plane. So XY plane is the working plane. So UCS Y and y-axis is 90 degrees. So the XY plane is now this particular face. Now certain times, let's say if I want to, I know the Z axis and I want to have the XY plane according to the Z axis. So here we have the UCS and here we are saying that the UCS would be as such that the Z axis starts from here and this is the direction. So what will happen in the due course? If you have this as the Z axis, press enter. So this will become the XY plane. So if you want to make this as a XY plane, put this as a Z axis. So let's try with it. UCS. So we know that for this plane, the Z axis is this one, the origin and here. Now you can see. So now you can save this positions of the UCS and then recall it and use it in your drawing or in your project. So how do I do it? Now let me put it at UCS world and let me change the UCS from time to time. Let's say if I have a face option and I want to save this UCS as a particular name. So here there's an option called settings. So here you have the name UCS. So orthographic settings and a lot of things are there. So just what I would suggest is, first of all, go to the UCS manager, UCS option. There's a named option, enter an option. So restore, save. So you want to save this particular UCS location as 1. So if you have gone to UCS world and you want that particular UCS location as the origin and as the XY to be restored. So now from this drop down list you can get it. Now let's see if I make this UCS face here. I want to save this UCS, so I go to UCS command and then I say name UCS and save this UCS and make it 2. Now I have got 2 locations, 1 and 2. So if I want to work at this face, I will select the 2 option. If I want to work in this face, I will select the 1 option. If I want to work in the top face, so I have to save this. Let's say I go here and save this, save like UCS, named option, save this UCS, let's say 3. Now you have got 3 UCS saved. So go to UCS world, 1, so you can work in this. So if this is your working plane, Again, this is 2. So this is your working plane. You can now do a lot of things. And this is 3. So this is the concept of UCS. And you can go with the UCS manager option and see that these UCS can be also set current and can be used at various times in the 3D modeling. So let's do some kind of practice with this particular example, and then I will finish off the session today. And in the next session, I will be talking about some editing tools of solid editing tools, some texturing tools and lighting, and go towards rendering. So here, let's say, so now I have this small layout of a room where I have a window and I have a door and a wall. So for that, first of all, I will create a layer. Let's say I will create a layer of a 3D wall. I'll create a layer of a 3D door, and I'll be creating a layer of 3D window. I'll tell you why. So we'll be doing some more examples of how. So let's put the window 3D window color different, 3D wall something different, let's say, and the 3D door, let me keep it a different color. Now since you have known about the layers also, so I think you won't be having a problem. Now this object is created in the 0 layer. Now here, let's say, if I want to create a wall, how do I do? Let's say I keep this sketch over here and I don't have the elevation right now, just to see how it works. So let's say if I have the layer, first of all, make the 3D wall layer current, and go for a boundary option. So here I have this boundary, this and this boundary. Let me have this boundary, the region. So if you go for a shaded option, you would see that this is a region. Now the height of this wall would be somewhat around 10 feet, right? So I created this 2 wall sections, but since there is a window in this section, so I create another, let's say, rectangle, make a region of it, extrude it, and put it till here. So now what I will do is go for a hide option. I will make this union so that it is a part of the building. Now go to the 2D wireframe, take this rectangle again. Now move this rectangle to the sill level, that is the 3 feet. So if I have this rectangle created, I will move this, select this rectangle, take the base point and move it in the z axis at the rate 0, 0, 3 feet. Now let's say the height of the window opening is 4 feet. So I'll take this to the height of 4 feet. Now I will subtract the window opening from the wall, and if you look into the hidden option, the so so here you can see that the how the wall openings are created. Now we will be doing a door opening also. So I just change it to the 3D basics so that I can use the layers from here. I can also do it in the 3D modeling workspace. So I'm just switching it off. So now let's say if I have a rectangle, I create a rectangle for the window. Now I move this rectangle at 7 feet where the door opening will end. So I say at the rate 0, 0, 7 feet. And then extrude this rectangle 3 feet high and get a union of this particular. So here you have the door opening created. Now if I want to put another opening at this face, so I'll go with UCS. I'll select the face here. Now so I have this UCS and face. Now other thing that you need to understand about UCS is if you want to work in this, if you want to see this plane parallel to the screen, there's a command called plan. So in the plan, the screen where the UCS is parallel, the face with which the UCS is parallel is now parallel to the view. Now let's say if you create a rectangle, let's say for the window opening, so I say at the rate 3 feet comma 4 feet, create a region of it and then place it somewhere at the mid, move it 3 feet to the cell level, and then you can basically extrude this in the Z axis, let's say minus 9 inches, and then subtract it from here. This is how you create a building with openings. So in the next sessions, I will be talking about how you can basically create doors and windows out of it. But this is the start. So go to plan. If you give the plan command, it will take parallel to the UCS. So here the UCS is XY. So you go to the parallel to it. But if you want to go to the UCS world, so now if you say plan, it will move parallel to XY. So you say 2D wireframe, and here you can basically say UCS is world already, and you can place the UCS at UCS icon at origin. So zoom on. So UCS is placed at origin. Now, so this is how you create different 3D models with the help of union, subtract, and extrude. There are a lot of other options. So if you want to create a column, let's say one more example, if I have a column, let's say I create more layers. So I go to the layer property, I create a column, I create a beam, I'll create two particular layers, 3D column and 3D beam. So let me give it a color so that I am able to understand it, and then I'll create a footing kind of thing. So it's very simple. Now let's say here you have a column, let's say at the rate. So I put the column layer as current. So I have a 9-inch by 18-inch column. So I copy this column at 10 feet distance, let's say. So if I do a region and extrude this, both of them, select both of them, and I extrude it at 10 feet. So this column will be generated. Now if I want a beam here, So I can have two options. First, I can place the UCS at the top face over here, create a rectangle or create a line, take the section of the, I can do an offset here because the UCS is here, otherwise I could not have done it. You know, create the profile of the beam, make it a region, and now extrude this beam to the depth, let's say minus 15 inches. Now you can have a union of it so that it becomes a single entity. So if you want a footing over here with a taper, so here you can basically you can go with the, again I come back here, just doing an undo operation. First of all, let's say my footing is 4 feet, so that it has a distance of 3 feet. Let's say I'm doing an offset. So let me undo it so that it is only the rectangle is there. So I have to remove the region, so I can explode the region, it will become a rectangle, that's not an issue. So let's say if I take a footing at let's say 3 feet offset from both of them, I can do a fillet. I'm just creating a footing to give you an example of how then I can do a example from a base plate. So here it is a curve option, so I have to have the fillet radius 0. So I can go with the multiple option and quickly I do a fillet here. Okay, so now let's say I create a region of this part and extrude it, let's say minus 18 inches. So I can have this, I can have the region over here, and similarly let's say if I want to have the I have a region over here. I'll give an example how we do it. I copy this object here. Let's say if I want to extrude it, but I will be having a taper angle, let's say. So I can have a tapered kind of footing. Let's say taper angle is 15 degree and the height is, or I can have it more than. So I can have the taper angle, the z axis, because this should be more than, let's say I'm having 120 degree and the height is, let's say, minus 2 feet. So I think the angle of taper has specified height of extrusion. So I have to have a taper angle and the height of extrusion I have to take along the direction. So here if I do the taper and then if I get my column, now I can extrude it. So we'll be doing an example where the taper angle I may be knowing, and then so the taper angle is the angle that the face makes with the z-axis. So here you can see the columns are there. So there's a footing. So we can have, let's say, we have a footing with the taper option of the extrusion. So There are various options. Let's suppose if you want to create eye sections, and you can try. Now let's say the last example that I want to give is of the staircase. And before that, I would like to also give you one command, that is a rotate 3D. How 3D rotate can be done. How it is different from the 2D rotate. So we can do this command rotate 3D and mirror 3D so that you can do some objects for the project. So I'm going back to the 3D modeling concept where we have these commands already there. 3D modeling workspace. So here we have these commands. So you can see in the solid, okay, you have this taper faces, you have this fillet edges. So okay, this will be covered in the next session. So let's talk about two commands called the rotate 3D and the mirror 3D command. So these are the commands which, so you have the layer option here in the advanced 3D modeling workspace. Okay, so how it works. Now if you have a rectangle and if you want to rotate this, so you have a rotate, so it rotates in a point. But if you want to rotate this in an axis, let's say between these 2 points, you have to take this as an axis and the angle anti-clockwise. So the command is rotate 3D, R-O-T-A-T-E 3D. Select the object that you want to rotate. So here I would just talk about only one option, the 2 point, the first point and the second point. Put your thumb around the axis that you have defined, and the rest of the finger will show the angle. So if I say 90°, it will stand up. So now rotate 3D is rotating an object along an particular axis. Now let's say if I want to rotate this object in this particular axis. So I have this rotate 3D and select this object. So this is first point, second point, and 90 degrees. So now it is going anti-clockwise. Now you can see if you put your thumb along the axis, the fingers will show you the rotation angle, positive direction of the rotation angle. So here you can see that if you have some objects, you can rotate them in 3D and then start working with it. Or if you have any object which is created in plan, let's say this is the object. You do a region, you do a subtraction. So now if you look into this, if you rotate 3D, select this object, and if you want to rotate this particular profile in between these 2 points and have 90°, now this is rotated, and now you can extrude this at a particular axis. Now why I am telling you, because I will be using this command for the staircase. So for example, I will be creating a elevation of the staircase. Let's say the riser of the staircase is 6 inches and the tread is, let's say 12 inches. So what I'm doing is I'm just copying this profile to a particular flight. So here we have, let's say, and let's say here we have the landing at 3 feet, 2 feet more. So this is 3 feet, and then the base slab is here, let's say 6 inches. And let's say I draw a soffit line here. So I have a 6 inches base slab, and I'm joining this along with this. Okay, and now what I can do is I can join this with this. Okay, so here I have this, I can do a boundary region. So first of all, I have to look into the layers. Now here I can rotate 3D, select this point and the x-axis, probably this one, 2 point and 90°. Now what you can do is you can select this region and give 3 feet as the height. So here you have the staircase created. Now you'll be doing the railings. I'll teach you how to do the railings also. So here you have this plane. Put the UCS here. Select, create a circle. Let's say dia 2 inches. And the height of the post is 3 feet. See? Now what you can do is you can copy this, taking this base point, at all the threads, and you can also copy it. Now you can join this points with the 3D polyline 3p, because 2D polyline will not be joining. So I can have this 2, 3, or directly you can join them till here, or you can till this particular point, and then you can have a straight line. So let me take it again. 3p, first point, and then the last point is at this particular staircase where the last flight is being there, and then you have, this is the profile of the 3D polyline. Now let's say if you have a pipe section over here, so you can have this 3D polyline a bit stretched, or you don't require it. So you can keep another 3D 3D object here, let's say somewhere here, or you can pull it down, so that you can increase the handrail. You can just put it there. Okay, no issues. So if you have a circle which is a cross section of the, you can put it here and use the sweep option. Select this circle, select this part, the handrail will be developed. So this is how you create the handrails. So just try with the handrails, you can do it, and the staircase. Similarly, if you want to take the path of the staircase, so 3D orbit, so we'll be doing some reinforcement detail also. So here you can go with parallel and zoom it. So now let's say the next stair starts from this particular face. So you can have a UCS face, put your UCS here, and then you can start developing the profile from this particular point. Let's say 6 inches, and then you have 12 inches. So let's say this is the profile that you have 12 inches, and then you have 6 inches, and then you have 12 inches. Then you can come back 6 inches, and then let's say you want to join it with this particular point, and then you want to have a boundary option. Pick a region, click the boundary, and then extrude it to this particular point. Now you can union it together. So union these two staircases together so that they become a single one. So this is how you create staircases in 3D modeling. So the last thing that I would like to discuss in this session is creating a basic reinforcement detail in a column. Let's see how it works. So let's take an example. I'll take a new file. So I go to metric and take a new file. So I have Remax, let's say, okay, a rectangle, let's say 230 into, let's say, say rectangle 300 into 300. So you have a cover of 25 mm. Let's say if you have circle of dia of 16 mm. So what I will be doing is I'll be just covering a basic how the reinforcement can be done. So let's say if I have this, I'm just taking one face. So just copying the center point, moving to the perpendicular here, and mirroring this option here, so that I can have the so 3 over here, and let's say I have the same 3 at this particular point. So this is a column section reinforcement that I want to do with the rebar. So let's create a 3D view of it. So go to the view. So you can have always have the workspace changed. Go to the 3D basics or 3D modeling, and let's say I take the view cube on and here. Now let's say first of all I would create the formwork. That is I'll create the column, or yeah, I will create the column, let's say 3000. And here what I would suggest is I would be creating I would like to have the stirrups first. Let's say the stirrups are diameter 8, and you can have a sweep option, and the object, the path is this. So you have the stirrups. Just move this stirrup, let's say 100 mm up, and then you can array the stirrups, and you can have a rectangular array here, in which the columns is 1, rows is 1, and the number of levels you can increase it with a distance, let's say 200 mm. Now okay, the number of levels that you want to give is 12, or you can increase the numbers, let's say by pulling this. So this is the stirrups that are created, and eventually if you want to create the rebars, so one of the option is to directly extrude it, the rebars, and then take a path of it and sweep it and give a bending curve over here. The other thing is that what you can do is you want to have the profile of it, so go with the UCS and change the UCS X and Y here, and now rotate the UCS. Now you have this UCS option, go with the X axis and rotate it 90 degrees so that the UCS become XY like this. Now what you can do is you can have the plan option. Now from the you can create a polyline which will be extending beyond here. So now you can see that the polyline is created as a path of this particular. So now you can have a sweep option, select this and take the path option as this path. So the rebars will be having some curves. So this is the way you create the rebar, or then if you want to create the, you can erase this. So this is how the reinforcement modeling can be done in AutoCAD. So with this help, you can basically show the reinforcement, how the reinforcement is done. And other options I will be teaching you in 3D how we can make it. So we are just ending the session.